Hi everyone, welcome to this last session of the course in which we'll be looking at how to test moderation or interaction effects when we have continuous predictors in our model. So to get us started, I'm just going to revisit a distinction I pointed to in the previous session looking at mediation and indirect effects, and that is the distinction between mediation and moderation. So as I pointed out last time, mediation can be thought of as addressing the question of how or through what process or mechanism one variable might affect another. So that's relevant where our theory and hypotheses suggest that the link between a predictor and an outcome variable is not direct but indirect. In other words, it has its influence via another variable or another set of variables. So there are two or more steps in causal terms between the predictor and the outcome variable via mediating variables. So in contrast, moderation is more relevant to the question of when or under what conditions an independent variable might affect a dependent variable. Now, as I pointed out last time, we've come across this already because interaction effects, as I covered them in the Between Participants ANOVA and Mixed Model sessions, are also referred to as moderation effects. So interaction effects and moderation effects can be used pretty much interchangeably as terms. So as an example from the Between Participants Analysis of Variance lecture within a general linear modeling framework, we looked at the question of whether group members might be less likely to perceive conflict with another group when their group has higher status compared to lower status than that other group. But we also wanted to test whether that in turn depends on another variable, the audience to which participants think their responses are being directed. Is it going to be their own group members who see their responses, or is it going to be members of the other group? So in setting up a model here, we have an independent variable, the effect of which is going to depend in turn on levels of a second independent variable, status, and its effect is going to depend on audience. So what we're looking for there is an interaction effect. And another way of putting it is the effect of the first independent variable will be moderated by the second independent variable, audience, or audience moderates the effect of status. So we're turning now to consider cases in which a researcher is interested in testing an interaction effect, testing moderation, where one or more of the predictors is not categorical. Now, the interactions that we considered in the mixed models and the Between Participants ANOVA lectures involved predictors or independent variables that were by and large manipulated and therefore categorical. So what can we do if we want to test interaction effects or moderation when our predictors or independent variables are instead measured continuously rather than being manipulated and categorical? So let's take an example here. A researcher who's interested in predicting levels of alcohol consumption, people's alcohol consumption intentions, might look to factors such as social influence, and specifically people's perceptions of the norms of the people around them. How much do other people around them actually drink? And what level of alcohol consumption do people around them approve of, for example? So they might have a basic prediction that perceptions of group norms will predict in turn people's own alcohol consumption. If we see other people consuming lots of alcohol, then perhaps we are more inclined to consume alcohol as well. But when is that link going to be stronger or weaker, that link between norms and alcohol consumption intentions? Well, they might look to theory within the social identity approach, which suggests that, well, the norms of a group will be much more influential, will be more predictive of our behavior, our own behavior, when we identify strongly with that group. In other words, when we see that group and our membership of it as an important part of who we are, compared to when we don't. Because if we don't see that group as particularly important to us, then maybe we just don't care as much about what other people in that group do or approve of. So in other words, what we're suggesting here is that identification with the group, the strength of people's identification with the group, will moderate the predictive effect of norm perceptions on people's own intentions and behavior. So how do we go about testing a moderation hypothesis here when we have at least one of the predictors being continuous rather than categorical? Well, once more, as I emphasized in the mediation and indirect effects lecture, the first and most important step is not a statistical one, but rather to have a clear, well-theorized and well-justified conceptual model. Again, the model can be usefully summarized often in terms of a figure. So here we might have an outcome variable, behavior, or in this case, behavioral intentions. And we've got a predictor variable, group norms, which we expect will, one way or another, predict or affect the outcome variable. But we've got a second predictor variable here, a potential moderator, identification. And to represent a moderation sort of hypothesis or an interaction effect schematically, we tend to do it as follows. So we've got an arrow here coming from the second predictor, but what it's leading to is not a variable, but rather the relationship between these two variables. So what this is saying schematically is the key role of this variable is to affect the relationship between this variable and this variable. So again, just to reiterate why it's so important to have a really clear and well theorized conceptual model before you get into testing moderation. Just like any sort of regression analysis in general, or general linear modeling analysis in general, it implies a causal sequence, a set of causal relationships with variables relating to one another in a specific way. Again though, just like for mediation and indirect effects, the statistics alone cannot tell you which variable goes where. How do you decide what's an outcome variable, a predictor, or the moderator? Especially if you haven't directly manipulated one of those variables. And the answer, again, is good theory, logic, common sense, and design. So ultimately, once more, be able to justify why one variable is specified as a moderator and not the outcome, vice versa, why one variable is a predictor and not an outcome. So assuming we've done that, again, another few assumptions of the techniques that are going to be running through in this session. One is that the predictor variable can be continuous or categorical. It could be a measure of something, or it could be a manipulation. Likewise for the moderator variable. Now a moderator variable here is just another predictor variable in the model. And the reason you would designate any variable as a moderator is, it's not a statistical property of a variable, it's just a useful description of how you see that variable working within the model that you're specifying. So because it is just another type of predictor variable, it also can be continuous or categorical. In turn, the outcome variable is usually continuous. Once more, it is possible to run moderation or test interaction effects when you have categorical outcome variables, but once more, that involves a type of regression that I won't cover in this lecture, okay, or in this lecture series. Specifically, you'll need to do a form of logistic regression, which I won't cover. So in effect, the techniques that I'm covering in this session require the outcome variable to be continuous. So, how might we test a moderation hypothesis when we have two predictor variables, but both are continuous rather than categorical? Well, I'm going to run through, first of all, a traditional approach using regression. This is proposed or popularized by Aiken and West. Now, once more, the reason for describing this is not necessarily to encourage you to do it per se, but rather to do two things. One is to sort of give you sort of a look under the bonnet or behind the curtain of what's going on in the techniques that I will encourage you to use instead. And the second reason is to help you understand these sorts of analyses when you encounter them in other people's research. This is quite or certainly was, a very widely used approach to testing moderation and interaction effects. So it's quite possible to come across it in research, other people's research that you read. So one reason for telling you about this process is to give you a foothold so that you understand what other people have done and how to interpret it. So, according to Aiken and West, what do we need to do? Well, the first thing we need to do is take those two continuous predictors, those two measured variables, and mean center them. So mean centering a variable simply means finding out the mean of the variable, the mean score in the sample on that variable, and subtracting that value from each score, each participant's score. Now that means is that it basically pulls the mean value of the sample down to 0. Okay, the mean of the sample will be 0 on that variable. Why do we do that? Well, the key thing that it does, it reduces the correlation between those two predictor variables, those two continuous predictor variables, and the interaction term, okay, which is a third term which is created by multiplying those two predictors together. Okay, and what this does in practice, it makes the coefficients of those two predictors in the model, in the output, interpretable as the main effects of each predictor, much like you would read them off as main effects when you had a two-way analysis of variance. You would have two main effects there, and you would read them off as main effects. Mean centering the two predictors when they're continuous allows you to do something similar. This is only necessary for the predictor variables, I should emphasize. So there's no need to mean center outcome variables or indeed categorical predictors. So it's only a step that you really need when we have predictors that are continuous. So let's look at what I mean by mean centering in practice. Let's pop to a data set here. So we've got variables relating to that research question about alcohol consumption intentions. So to look at whether identification with the group moderates the effect of norms, perceptions of norms on alcohol consumption intentions, we first need to mean center those two predictors, identification and norm perceptions. Okay, so the first thing we need to do is find out what the means of those two variables are. So I'm going to go to exploration and descriptive statistics. I'm going to ask for the mean of identification and of perceived norm. Okay, there's various other bits of information in this table, but the key thing here is we've got the mean value for identification and for perceived norm. I just click on data now, and here this is just the next column to the right. I'm going to click on compute and double click that. Now we can compute a new variable. Now this is going to be the mean centered version of, let's do norm first. So we're making a new variable which is the mean centered version of perceived norm, and you can call it what you like. I'm just calling it norm centered here for clarity. And what that is going to be is simply from this drop down menu, click on the original variable, double click on the original variable. This is the equation. It's going to be perceived norm minus the mean for perceived norm, which was, look down here, 10.306. 10.306. And there we have the mean centered version of the norm variable. Now let's do the same for identification. Click on the next column, a new computed variable, and let's call it identification centered. Once more, that's just the original variable, identification, minus the mean for identification. Now, because that mean itself is a minus number, I'm going to put it in parentheses because it's the minus of a minus number. Okay, so minus 1.943. Close the parentheses, and there we go, the mean centered version of identification. Now, the way to check, just get rid of that, the way to check that that's worked is add the two new variables, norm centered and identification centered, to your descriptives table. And you'll see, first of all, two things should be happening. One is that the standard deviation should be exactly the same. So the distribution and spread, if you like, of the variable in the sample should be exactly the same. So the original norm measure and the mean centered version have exactly the same standard deviation. Likewise, identification. But now the mean scores on both of those are 0. Okay, that was the original mean, and now that's the mean for identification centered and the mean for norm centered. Okay, so that has worked fine. The next step is to create the interaction term. Okay, now what that means is you simply create a new variable by multiplying together scores on those two mean-centered predictors. Now that's actually also what happens in ANOVA. The interaction in an ANOVA is simply created by multiplying together the contrast weights for the two main effects in the design. Okay, so it is really just another version of, or an extension of, what we have already done in analysis of variance. Okay, then, we simply run a regression analysis, a regression model, in which we regress the outcome variable as the outcome variable on the two mean-centered predictors and the interaction term. Now that is just exactly like the equivalent of a two-way analysis of variance. It will provide you three estimates. It'll give you tests of the two main effects of those predictors and the interaction between them. So let's run through that in practice. So we've got our mean-centered versions of our predictors now. So let's run a regression analysis where we have an outcome variable, people's alcohol consumption intentions, and we have two predictors. Now predictors here are entered as covariates, remember, if they're continuous. So we've got norm centered and identification centered. Okay. Now a couple of things here. Let's just ask for the extra bits and pieces that we should normally do as a good habit for regression analyses in jamovi. And just one last thing here is, we'll notice that in the output we've only got two effects. Okay, we've got the effect of norm and the effect of identification. So unlike in a general linear model approach to ANOVA, if you remember back to that session, it does not give you a test of the interaction effect by default. So what we have to do is go to this drop-down menu here under Model Builder. And what this is saying here is that, well, what jamovi is asking for or giving us by default is simply the main effects of those two. What we need to do in addition is select them both, and from here also ask for the interaction effect. Okay, norm-centered multiplied by identification-centered. Now we've got our three effects, the two main effects, and this is the interaction. One final thing I just want to do here is drop down to marginal means and make sure that this is ticked here. Okay, marginal means plot. And I'm going to ask for both together and move them across. And what that will give us is a plot of the slope of the norm predictor at different levels of identification. Okay, low, mean, and high levels of identification. Okay, so let's go back and walk our way through that output. So here's that regression table in which we've got the three effects, our two main effects, the main effects of the two predictors, and the interaction. So the main effects here, well, what have we got? Well, perceived norm has a highly significant association with intentions, but identification does not. So the higher people's perceived, that the more alcohol that people perceive other people as consuming, the higher their own alcohol consumption intentions. Okay, a positive coefficient. But identification in itself does not predict intentions. In turn, the interaction between them is also highly significant. So one way of putting that, so a couple of ways of putting that you might see written down, is that identification moderates the association between norm and intentions, or the main effect of norm on intentions is qualified by the interaction. Okay, in other words, in order to make sense of the association between norm and intentions, we can't just look at the main effect. We also have to look at the interaction, and what it suggests to be the dependency of the norm effect on identification. Okay, and that's a sort of an APA version of how to write up that interaction effect. Just turning to that figure that we asked for, I just want to point here to a convention, not a rule, but a convention. All right, and that is to estimate the slopes of the predictor variable. Okay, so remember, the steeper the slope, the stronger the effect, the stronger the association. Okay, so the slope of the predictor, so the slope here is of the effective norm as you move from low to high. And what this is here is broken down by different levels of the moderator variable identification. So we have the slope, this blue line, the slope of norm, estimated when identification is 1 standard deviation below the mean, so low. The grey line is the slope of the norm variable whenever identification is at its mean level, and this sort of gold line is the slope of norm whenever identification is 1 standard deviation above the mean. In other words, when it's relatively high. Okay, so it's a nice way of visualizing how the slope or the effect of our predictor variable changes depending on the level of the moderator variable. So in terms of sort of presenting a more sort of integrated or up-to-date way of approaching that sort of test of an interaction effect, a moderation effect, when we have continuous predictors. Now, I just want to go back to something emphasized as a sort of a running thread throughout all of the sessions, that all of the approaches we've talked about, analysis of variance, regression, mediation, moderation, are all just different instantiations of a general linear modeling approach to testing our hypotheses. So, as you remember from what I emphasized in the first part of the regression session, is that pretty much any linear multiple regression analysis can in principle be done using ANOVA, or a general linear modeling approach, and vice versa. So selecting one approach over another is actually mainly a pragmatic decision about the ease with which we can extract relevant information from the output given our research questions and the design of our study. So what I'm going to do is test that, run that model again, test that exact same interaction or moderation hypothesis, but this time not using regression, but rather the GAMLJ module, which I used for testing, for running between participants ANOVA analyses and mixed models. Okay, so I'm just going to jump back to that. Here's our data. Now this time I'm going to go not to regression but to linear models and general linear model. And I'm going to specify a model where we have intentions, again, as our dependent variable. So it's pretty much exactly the same as the regression-based model that I set up. We have, this time, 2 continuous predictors, norm and identification, which are entered not as factors but as covariates. Now, as I'll show you, you do not, when you use this approach, you do not need to mean center by hand your predictors. Okay, so now what I'm going to do is just enter the original variables, perceived norm and identification. Because if I just move down here, if you look under covariate scaling, by default, this module will automatically mean center predictors for you. Okay, so you do not need to mean center predictors by hand before using this approach. Okay, but it is also just worth checking that they have indeed been mean centered in the analysis by checking this. So again, as we can see, by default, it's only giving us the norm and identification main effects, but not the interaction. So again, we have to go to the model drop-down menu, select both of those, and also ask for the interaction in addition to those 2 main effects which were already there. And now we can see that the output looks pretty much like a two-way ANOVA table, as we saw in the opening session. So we've got the main effect of perceived norm, we've got the main effect of identification, and the interaction between them. And in the parameter estimates table, we have what basically is the regression version of the ANOVA table with exactly the same output in terms of the significance. Okay, but in a more sort of regression style format where you've got a regression coefficient, standard errors, etc. So what do we see from that? Well, the fact that we get exactly the same estimates. Okay, so if we compare this, which was the regression style table from that output, to the actual model that we ran in regression, it's exactly the same. So that analysis is consistent. Let's think about how a researcher might interpret this. So the analysis is consistent with the hypothesis that the association between perceived norm and consumption intentions would be moderated by identification with the group. However, again, as we saw with the in the ANOVA and mixed model lectures, often interaction effects involve slightly more precise predictions about what that interaction looks like. Okay, so the researcher had a more specific prediction than simply would they interact or not. Okay, instead they were predicting that people's own consumption would be predicted by perceived norms more strongly when identification with the group was high compared to when it was low. So how do we test that? Well, what it requires is analysis of the slope of perceived norm at different levels of identification. So our analysis options here are to run something which is very much like the simple main effects analyses that we saw in the ANOVA and mixed model sessions, and specifically simple slopes analysis. Now, whether something is a simple slope analysis or a simple main effects analysis, I don't think there's anything fundamentally different about those. It is simply slightly different terminology for when the predictor is itself continuous, so a simple main effect, or categorical, in which case, continuous, in which case it would be a simple slope, or categorical, in which case it would be a simple main effect. But essentially it is the same thing. Okay, so a simple slopes analysis therefore tests the slope of the predictor, the norm perceptions, at different specified levels of the moderator identification. So let's have a look at that. Back to our analysis. This is what we've just run. So if I run down here to this drop-down menu, simple effects, I'm going to ask for the simple effects, just as we would in ANOVA or mixed models. Ask for the simple effects of the main predictor, broken down at different levels of the moderator identification in this case. And finally, just to help sort of illustrate the interaction, I'm going to ask for a graph. On the horizontal axis, I ask for the main predictor, the perceived norm, and I'm going to ask for that to be broken down in separate lines at different levels of identification as the moderator. Let's see that plot. Okay, there we go. And the simple effects analyses. So one thing here about the simple effects analyses is, again, what it's doing is testing the slope of the perceived norm predictor at specific levels of identification. All right. So again, the convention is low, mean, and high. So low being one standard deviation below the mean, high being one standard deviation above the mean. So when identification is low, one standard deviation below the mean, the slope of norm, as it predicts intentions, is not significant. Okay, but it is significant at mean levels of identification and at high, one standard deviation above the mean levels of identification. Okay. And looking at the graph, this helps us to visualize it. So as people's perceptions of alcohol consumption norms around them increase, okay, or are higher. This is the slope for the blue line. There's virtually no association between that norm perception variable and intentions, people's own intentions, when people themselves don't identify particularly strongly with the group. But that slope, okay, that association between norm and intentions, people's own intentions, gets stronger as their own identification with the group also gets stronger. Okay, so at mean levels, we have this grey slope, and then an even steeper slope, okay, whenever identification is high. So that's it for this first part of the session. In the second part, having now demonstrated sort of a basic test of moderation analyses using two continuous variables, I'll go on to consider how you might test moderation or interaction effects that involve different combinations of categorical and continuous predictors. Okay, join me for that.